everyone. Hello, everyone. Welcome to All About the Data SQL Saturday. Woo woo. One more week down. Welcome, everyone. Joining from the UK, Stanley. Got Ugochi in here. Y'all sound off where y'all are joining from in the comments. I don't know if y'all seen that comment, but like she said, make sure y'all like the video and subscribe while we're getting started. Probably wait a few more moments to let other people in. Hey, Steph. Hey, Linda. Welcome, everybody. Welcome. All right. I think we go ahead and get started. All right. So like I said, welcome to SQL Saturdays. I'm Jelly, Tech Girl Jelly on Discord if you'll find me. I was a military analyst before. I'm getting into data analytics. I did a Google certificate and I do a lot of analytics at work. So yeah, welcome everybody. I'm a beginner. So we're going to be using these study sessions to get our skills up. Jonathan from Smyrna, welcome everybody. So yeah, I'm going to introduce the other ladies who are going to be involved today on today's session. You ladies can chime in and introduce yourselves to everyone.
Yeah, so I am Lex, Alexis. I'm currently a health information specialist. You can find me on the Discord, mainly in the healthcare analytics channels. I'm also a community manager for Discord, so you can always reach out to me on there. But I'm happy to be here helping you guys and answering any comments and questions you guys may have during the session.
Awesome.
Hey everyone, this is Ugochi. I'll also be moderating today and answering any questions in the chat along with Lex. You all know me, I work in public health and I have experience with statistics and some data science. And I'm mostly in the Discord as like a community advisor, so you've probably seen me in there.
Hi everyone, my name is Susan and I'm a master's student at NYU specializing in business intelligence. I have prior experience working with SQL and I'm currently working towards leveraging data-driven decisions to improve business areas, operations, sales, marketing, and so on.
Hi everyone, I'm Evelyn and I currently work as a customer success consultant. I hold a master's in information technology and have experience in using SQL, Excel, and Tableau for analysis and visualizations.
Awesome. Thank you, ladies, for introducing yourselves. Hey, Brandy. Hey, everyone in the comments. Thank you guys for joining today. We are going to get started. So today we have a few things to go over. As far as getting set up, if you want to follow along, here are the instructions to get set up. So we're going to be using SQLite Online. And here's some instructions. So go ahead and make sure you choose Postgres for your database, and then go ahead and download the file. You'll see that right there as well. And some links should have got sent out as well for you to go check that out. So I'll give y'all a few minutes to get set up. But hey, everybody. All right. Who do we have first? We have Susan first today.
Okay.
Perfect. All right. I'll hand this over to you, Susan.
Hi everyone, like I said before, my name is Susan and I'll be taking you guys on joins today, joins in SQL. So joins is just a concept or a syntax that we use to combine two or more tables. And joins can be used in different ways. We can use join to join a table to itself or to join one table to another table or even three or four tables depending on what we are trying to get from our data set. So one of the important things you must know about joins in SQL is that the tables must be joined using a condition. You can't just run a join syntax without using a condition. Another thing you have to know about joins is that you could use a where clause. You can also group your data when you use a join, and you can also order by. You could also do most of the things you could do in regular SQL queries with a join query. So the first thing I'll be talking about, the first type of join, we have different type of joins. We have inner join, we have left join, we have right join, we have full outer join, and we also have cross join. But for the purpose of this class, I won't be going through cross join because it's a little bit more complex than the remaining joins that we are used to. So I'll start with inner join. I don't know if like most people on this call are like familiar with like sets in mathematics and doing all of the Venn diagram and stuff. So I'll just be using this diagram to illustrate inner join for us. So inner join is joining two or more tables or one table to itself, and then your data set gives you a result where you get only the matching rows from the left and right table. So the keyword here is only the matching rows. So you have this first table in this illustration, and you have the second table, and then you can see the shaded section where the query result is going to be gotten from, where you have just the part of the first table and the part of the second table that is common to both tables. So you get only the matching rows from the left and the right table. That's what your query result is going to give you. So I'll be moving on to the next type of join. Yeah, the next type of join is left join. So just like the name implies, we are joining on the left table. So what this query gives us is we get our data set that includes all rows from the left table and the matching rows on the right table. So in this type of join, you can see from this Venn diagram or from this like illustrated tables using circles here, you can see that the table A, every part of table A is gotten in this query, and just the part of table A that is common to both table A and B would be gotten from our query set. So that's why I use this diagram to illustrate it. You can see the section that is common to table A and table B being shaded, and every other part of table A being shaded also. So for the purpose of like writing queries, so sometimes like when you write your left joins or your right joins, sometimes you need to like get some part of the like you're trying to see only the part that is like exclusive to the left table. So you could also like use this diagram to illustrate like, okay, I'm trying to like get the part on I'm trying to get the rows on the left table that is exclusive to only the left table and does not exist on the right table. So this could also illustrate how that works. Also, you could also be trying to see where the right table is null on this other table on the join query. So you see this white part that is not shaded could also give you a result of the join on these two tables where the right table is null. So it takes me back to the second point on this on my PowerPoint slide, where you see that the rows that exist on the left table and do not exist on the right table will be returned as null. That is this part that is shaded as white on the first diagram. So moving on to the right join. Um, so right join is very, very similar to the left join. It's just that it's just the opposite. Instead of joining on the left, you join on the right table, and every row on the right table is returned, and only the matching rows on on the first table is returned. So just like the left join too, only the rows that exist in the right table can also be queried by by the illustration from on this diagram, seeing that I only shaded the part on that. So moving on to full outer join. Yeah, moving on to full outer join. So the full outer join is basically a combination of the left and right join. So this gives us a query result that includes all the matching rows. It includes all the rows on the left table and all the rows on the right table, including the matching rows on both tables. So for the purpose of some queries you might be writing, or depending on what you're trying to query from your database, you might sometimes need to see every row on your first table and every row on your right table except the matching rows. So this second diagram just illustrates how this works and how you can illustrate query your result without giving without including the matching rows on both tables. So I think this is like good enough introduction into what our joins are and how we can use them. So I'm moving on to the exercise now. And yeah, next slide, please. Um, yeah. So I just the database we are using has like a couple of tables, like it has like different tables. So I just put up some questions based on the kind of questions I see, um, like people ask during like interviews, not just interviews, like regular questions. So sometimes they might not just tell you to like, oh, right join this table, left join. So they give you like a question, and then you now use your knowledge of how SQL works to know that okay, you're supposed to join one table to another table, or I'm supposed to do an inner join, I'm supposed to do a left join. So I just try to illustrate these questions in the way you see joins questions in real life situations, not just them telling you to like join on one table and another table. So the first one is the sales team wants to know the best selling product. How would you get this data? So this question is you have an idea of okay product, and then you're trying to know the best selling product. So I'll just try to share my screen and show us what the database looks like. So I can tell you the tables I'll be working with for this first question. Let me know if you can see my screen, please. Can everyone see my screen?
Yes, ma'am.
Okay, so I already wrote these queries, but I'll be writing them again, just so I would explain what I wrote. The first question is we are trying to get the best selling product. Um,
1 second, Susan. Do you mind just zooming into your screen? It's a bit blurry for us. So if you could just enlarge it a little bit more. Yeah.
is it better now?
That's
Can you
perfect.
guys see that in the comments? Everyone?
Okay, the first question I talked about just moving on to my slides. Sorry. Okay, the sales team wants to know the best selling products. How would you get this data? So the way I would approach this question is to know like what exactly are we trying to look for. So I can see a keyword products, and I know that I'm trying to look for the best selling product. So I would go through my database to see what tables we have and the options we have. I can see a product table. So the first thing I'll do is to be exploring this table. What columns do we have? What columns do we have? So I can see a product name, I can see a product ID, I can see so many other columns that are in this table, the product table. So another thing I'll be looking for is best selling. I'm trying to see okay, maybe others. I'll look through the others table and I can see the others like contain it's like a table that like combines probably the other details and products. So I can see other ID, I can see customer ID. So this table, to the best of my knowledge, just shows us what customer bought what on and what employee probably sold product to what and the other date and many other details that we could find here. But this table doesn't still show me the other quantity or what the person bought. I can only see the idea of an order. So I went for that to look through the other tables and I saw another table called other details. So looking through the other details table, I can see order ID, I can see product ID, and I can see unit price, and I can see quantity. So I can now say that okay, I can decide to join my other details to my product. Um, a minute, please. To my product, just to see what information I can get from these two tables. So looking at my product tables, I have product ID. On my other details table, I also have product ID. So I know I can do a join because I can tell that every product that has been sold is in this other details table. And then for each order, I also have the order ID. But for the purpose of this query, I wouldn't need my other table because I have every information I need on my other details table. So I'll just wipe this off and rewrite it. So what I'll be doing is I know that I am selecting from two tables. So I would select and then I would come here to write my from. Then I know I'm selecting for my product table. I'll just give it an alias P. And I'm also selecting from my other details table. I'll give it an alias OD. Then I'll look through these two tables to see what columns are common to this table where I can perform my join on. So I would come down here because I need to join these two tables. So I have order ID here and I also have like product ID on my product table. So I would say inner join because I'm trying to see the matching rows on both columns. I'm trying to see the products that have been sold, and I'm also trying to get the quantity. So I'll do an inner join. Then the syntax of doing a join, you do an inner join on. Part of what I mentioned in the slide, that we do a join based on a condition. A condition must be involved. So inner join on. So now I'm going to type my condition, p dot product id equals od dot product id. So I could just select star just to see what I have in this table. When I run this, so I can see there are so many columns because I'm doing a join on all the columns, but I do not need to see all the columns. So I can specify the columns I'm trying to see. So I could say I want to see the product name, of course. Then I can also say I want to see the quantity. I can also say I want to see the product ID. That will be P. So giving the products, giving the tables an alias is just a way to just make things easier for me when I'm like trying to get columns specific to each table. So I wouldn't want to be typing products dot product name, products dot product ID, because sometimes my joins can be like very long. I could be joining like 3 4 tables, and just to make it easier to read and easier to work with, I give it an alias. So p dot product name means product name is, it exists on the product table, and product ID also exists here. So I want to see the other quantity. So I will do an od dot quantity, and I think that will be all I'm trying to see, because the question says they want to see the best selling product. So trying to see the other quantity and the product name gives us this, but this is not all, because I'm trying to see the best selling product. So I can as well order my query result. Sorry. Order by I could also give this an alias called say quantity. Then I can say order by quantity descending. So descending means I would see my most sold product first when I run my query. So just to make this more readable, let me just do it this way. So when I run this, see what it gives us. So let me just expand this, so we can see the product IDs and we can see the quantities that have been sold. So this is like a query that we can give. So if the sales team says they want to see maybe the top 5 best selling products, we could also do a limit 5. That way we see the top 5 best selling products. If I run this, um you would see that I only have 5 results in my query. So we can see the quantity 130, 120, and we can see the product name. So this is like a very good way to answer that question. We could even go further to put the category, but because of time constraint and me just being like starting from like the simple stuff, I wouldn't put the category like here, because if I have to do the category, I have to join on that table, the category table. So I'll be moving on to the next question, which is HR team wants to measure performance of each employee and wants to know the employees that have not fulfilled any order. How would you get this data? So doing this, I could look through my database just like I did before, try to see what tables I could try to get this data from. I can see that there's an employee table, so I could just explore this table to see what details I have here. So I have the employee ID, I have the last name, the first name, and other details that belong to each employee. And we can also see that the employee ID here is the primary key, which means that the employee ID every other column here identifies each employee. So all of these other columns identify each employee. So an employee is unique to this employee table. I could also say, okay, you want to see the performance, you want to see sorry about that. I want to see measure the performance. So how can performance be measured? They said they want to see the employees that have not fulfilled any order. So it means I would be working with my order table, and I'll just look through my other, because I have other and I have other details. So I'll look through the 2 tables to see what columns I'll be working with. So looking through my other ID, I can see employee ID, which means employee ID is a foreign key to this table, meaning for each other, an employee must have fulfilled that order. So I now know that I can work with my order table and my employee table. So me writing this query, I already wrote it here, but I'll just wipe it off and write it again, just so we understand carefully. So I would select, I usually like to write my from before I write what I'm selecting, because I really do not know what I want to select before I know the table I'm selecting from. So the first table I'll be selecting from will be my employees table. I'll give it an alias also, just like I did. Then I would join, but this time, since I'm trying to see all the employees that have not fulfilled any order, I will do a left join, just so I can see all my employees and I can see the employees that exist on the others table. So I will do a left join. Um, sorry, left join. Others E. Then others O. Sorry. What? Then I would put on E dot. So it's very easy to work with. You can see all the columns that are on the employee table. So I would pick employee ID equals O dot employee ID. So this way I've been able to join my employees table to my others table. And what this query result is going to give me would be all the employees that exist on the employee table and only the employees that exist on the others table. So doing this, I would try to see, of course, I want to see the employee's name based on the question. They want to see all the employees that have not fulfilled any other. So the best columns to pick from here would be the first and last name. But because I want to see my first and last name together in one column, I would do a concatenation. I would concatenate e dot first name, comma, then I would do a space, then e dot last name. Then I'll select this as full name. Then also, what else could I want to see? I can also want to see the O dot order ID. So when I run this query first, I would be seeing all my employees and all the employees that also exist on the others table. Oh, sorry. I join others. Oh, oh, right. So I can see the full name of all the employees and the others. That's the O dot order ID. But now the question is they want to see all the employees that have not fulfilled any order. So I could also put a condition here to say where O dot employee ID is null. So what this means is I want to see all the employees that have not fulfilled any order. So I want to see the first name and the last name of all the employees that do not exist on the employee ID table. So when I run this query, I wouldn't see any results. So this what this means is there are no employees so far that have not fulfilled any order. So it means in this database of employees and customers and sales, all the employees have fulfilled an order. So this when you give an HR this result, they can okay see that okay, yeah, the employee is actually performing well, and there's no need to like probably sanction any employee for not fulfilling any order so far. So this is a very good way to see what does not exist in one table based on what exists in another table. This using your left or right join is a very good way to know that. So I'm moving on to the next question. The supply chain management team wants to know all suppliers whose products have been discontinued in order to update their supplier list and manage inventory properly. How would you get this data? So moving on, I could just explore my table. So we see you can see that there's a keyword supplier. So obviously there's probably a suppliers table or suppliers exist somewhere within this table. So I can see a suppliers table here. So I'll just go through this table to see suppliers. We can see that this table is primary to suppliers. So each supplier exists on this table. So because they want to see the product that have been discontinued. So I know that I'll probably be working with my product table too. So I'll go to my database and look through product table to see. So looking through the product table, you can see that supplier ID exists here as a primary key. And then we also have discontinued as a primary key. So I will just walk through this just to see how it works. Sorry. I think I already wrote that, but I will just write a new one. I need to minimize my screen. Uh, okay. So I would say select, just like I did, select from all the suppliers, right? I want to see, I'll select for my products first. I'll give it an alias P. I would write join because I want to see all the suppliers. I'll write join suppliers, give it an alias S. So since we have a condition, I would do my write join on P dot supplier ID equals S dot supplier ID. Then we want to see the products that have been discontinued. So I would say where P dot discontinued equals 1. So before walking through this table, I already looked through the table to see how the discontinued is represented. So looking through, I realized that discontinued 1 means the product has been discontinued, and discontinued 0 means the product has not been discontinued. Or that's my assumption basically, because I really do not know why I'm how it was represented. But I mean, using 1 0 means 1 has been discontinued and 0 has not been discontinued. So I'll just try to see, okay, S dot supplier name. Okay, say supplier ID, then S dot company name. So I think these two information, and I also want to see the product, of course, P dot product name. Yes, and running this, I can see my supplier ID, I can see the supplier name. I would also want to see probably since it's the company name and it's not an individual name, I can also want to see the contact name, and I probably want to see the contact title, just just following the question because you want to see the suppliers that whose products have been discontinued. So I mean, it makes sense to just give them the name of the contact and the name, the title of the contact. So in case they want to reach out and say, "Oh, we're not buying products from you anymore because this particular product has been discontinued." So it's an easy way to reach them. I mean, that's my assumption. So I will run this query just to see. So you can see the supplier ID, you can see the company name, specialty biscuits, contact name, and the name or the title of the representative and the product name. So all these products have been discontinued. So this would be a very good data set to give the supply chain management that wants to see all the products that have been discontinued. So this will help them, update their inventory or do whatever they want to do with this list. So moving on to the fourth question. So this for the fourth question, this is a little bit more tricky than the others. So the marketing team wants to know the customers with order quantity lower than 5 units in 1998. So this is just me going through the database before to know the years that data was imputed into this database. So the reason why they're trying to know this is to offer them promotional discounts to encourage more purchases. So as a data analyst, they want you to give them all the customers that have ordered less than 5 units in 1998. So I mean, the way to go about this also, we can see keywords, customers, we can see quantity, order quantity, and we can also see, there's a year, there's order. So we know we are probably working with the order table, we're working with customers table. We can see that there's a customer table here, and the customer table has customer ID and other information about the customer. And then we can also go through our order table to see. So we can see that our order table has um customer ID, and we're also trying to see quantity, but other quantity does not exist on this table. So it also makes sense to look through the other details table just to see what we have. So we can see that we have order ID on the order details table, and we also have order quantity. And looking through the orders table, we have order ID also, and then we have customer ID, and then we have our main customer table. So doing this, it makes sense to join these three tables to get the details for um the marketing team. So I would select from, so I'll be selecting for my customer table first, of course. Customer C. I'll just put the third place so it's readable. Then I will do an inner join. So inner join orders O. Then I'll put my first condition because I'm joining customers to orders. So what condition am I joining these two tables on first? So I would say on C dot customer ID equals O dot customer ID. So this way I've been able to join the customers table to the orders table. So I can see all the customers that have placed an ID on this from this table. But that's not what we need. We need to see the quantity that each customer have placed and being able to filter checking the quantity that each customer have placed. So I mean I could just run this to see customer dot um maybe customer dot company name just to see the name of all the customers that have placed an order so far. And if I run this, I would see all the customers that have placed an order. But going further, I would also need to join again. I'll do another inner join. Oh, inner join orders order details OD. Then I'll put a condition on OD dot order ID equals, oh sorry, let me just start from O dot order ID equals OD dot order ID. Then doing this, you can see, I mean, it will give us pretty much the same result, but now we've been able to see, we can see the quantity. So if I want to see the quantity, I know that quantity exists in my order details table. So I would come back here to say, okay, let me see the quantity that each of these companies have placed an order for. So I could also want to see, say C dot maybe contact name, because they want to see. I could also say C dot probably phone number. I could say C dot what else, maybe their address and other quantity. So running this, I can see the quantity that this each of these customers have bought so far. Then because the marketing team is trying to run a promotional discount and they want to know the customers that have placed an order lesser than 5 units, so I would write a condition saying where OD, I'll just give this an alias as quantity. I will now say where quantity less than 5. So running this, um sorry, right, just leave it as OD dot quantity. Okay. Uh, just give me a minute. I think I already did this before. can't seem to find the latest query I'm writing. Um, Let me just edit this. I can't find the query I was writing before. I don't know. I'm not really sure I work with this Postgre. So od dot um okay, it's basically what I was writing before. So I joined the customers table to others table, then I also joined it to the other details table, and I joined it on the other ID. So I'm trying to see where the other quantity is less than 5. And then I could also say, since they want to see that for 1998, I can also say and um, extract, extract year from, okay, O dot order date equals 1998. Just see if this will work. Uh, extract here from apologies. So yeah, we've been able to get the customers that have ordered less than 5 quantities in the year 1998. So just like I was explaining before, I mean, I lost my query. We've been able to we joined the customer table to the orders table, then we also joined the orders table to the other details table, so that we can match each customer to the quantity that they've bought, and then also filter using the quantity that they've bought and the year that they bought this. So I mean, giving the marketing team this I could also show the quantity. Probably I could do, oh, okay, I'd like to put that before the other date. O dot quantity, od, sorry, dot quantity. So running this, you can even see the quantity that each of them have purchased. So you can see most of these guys, like, they've bought two. So I can even decide to even order by quantity, but just for so they can see the ones that have bought the least quantity first. So I can say order by od dot quantity in an ascending order. That way would see, so we can see a lot of these guys have bought just one item so far. So I mean, this is a very like good data to give the marketing team, so they can run we can run promotional discount messages to these guys just to like increase purchases. So the important takeout from all of this is when you are doing joins, nobody will explicitly tell you to do a join in any question they're asking you. They'll just give you a question, and you'd have to figure out the tables that you need to join and how you would join this table, if you have to perform a left join, a right join, an inner join, or an outer join. The reason why I didn't give an example on outer join is in most cases we do not always do an outer join when we are running most of these product question queries, because most times you're trying to see something that exists in one table and doesn't exist in another table, or what exists in both tables. And sometimes from this slide, this this guy, you can see that this missing part is also like an inner join. So you can also use an inner join to run where matching values are null. So you could also say you could do a join on an inner join and say where od, where one table equals to this table equals null. It will also give you the same result using an inner join, so you don't necessarily have to use an outer join for it. So I think at this point I'll be taking questions. I am done. Any questions, guys?
Yeah, just give them a couple minutes because there is a little bit of a delay when it comes to broadcasting to the YouTube channel.
Okay.
So just give them a couple seconds.
I don't see any questions being commented.
Yeah. Hope I
All
can
right, no
hear.
questions.
Looks like they're loving it though. Someone had said it's a very good explanation. So thanks, Susan. That was really great.
Okay.
Oh, thank you, Susan. So that was joins, y'all. All right, pop quiz. How many types of joins did Susan go over? Any of y'all know? Was y'all paying attention? Can y'all drop a comment? How many different types of joins that Susan went over?
Three joins, I think.
Who said 3?
Oh, sorry. I was answering the question myself. I'm sorry.
You
Apologies.
cheating, Susan. You said
Well, but
3.
it wasn't three anyway. So yeah, I got it wrong anyway. So Tony probably
Alexis
get it
said
wrong.
3. Emmanuel asked, how do we know the keys to use for the join?
Okay, so for that aspect, I'll just go back to the database. So it's always interesting to look through your tables first. So you can see customers table here, and you can see that it exists as a primary key in this table. If you go through your others table, you would also see customer ID, but it doesn't exist as a primary key. So it means customers exist in this others table because they have bought an item. That's what it means. So it will make sense for you to join the customer ID, to do your join on your customer ID using your customer ID as a key because it exists on the customers table and it also exists on the others table. So in the case of joining others table to the other details table, you can see that we this others table, I think this others table, to the best of my knowledge, is a table that like it's like a table that like brings all the details together. So you can see that other ID is the primary key, and you can see customer ID, you can see employee ID. So looking at this table alone, I know I can join I can join others table to the customers table. I can also decide to join into my employee table. And these are just the IDs I can join it on. But looking through my other details table, I can see order ID, I can see product ID. So it means I can join my order details table to my order table, and I can also join it to my product ID table. Looking through my product table, I can see a primary key here, the product ID. So it means product ID can be joined to any other table that has the product ID there. So looking through my suppliers, I can see that my supplier sorry, looking through my product table again, I have my supplier ID here. So it means I can join my supplier ID to my suppliers table. So I mean, you just have to just first of all look through your tables properly before you even decide to join anything. You have to understand the question. You have to understand what you're trying to get. And then you have to look through the tables to know the tables that are relevant to the query you're trying to work with. So once you look through the tables, you can tell that okay, supplier table, I probably need to join it to my product table to get products that to get the suppliers for each product. I mean, so I can join my orders table to my product table to know the quantity that has been bought for each product. I can also join it to my order table to know the quantity for each order. Like it just depends on what you want to do. So that's why like I try to put my questions in like very practical format, because nobody's going to explicitly just tell you to join two tables. So you just have to know what tables you're joining, how you're joining them, and the keys you'll be joining them on. So I think with time, it takes practice, it takes, I mean, you working with databases very well to like do proper joins. So my best advice to anybody that's trying to like work with joins now is to just keep practicing and just, I mean, you could see that when I was working through my queries along the line, I kept, especially this three table query, I kept like querying it before I finally got to my final result. So after I joined two tables, I tried to see what I could get using those two tables, and then did another join again before I got my result. So it would be very smart for you to like try to like see the result of your query along the line before you like fully write your full query. And also you might not even know what you want to select, so it's always advisable to like put your tables that you're trying to select from first before you now know what details you're trying to select from each table. Because you can see here I selected customer ID from customer table, I selected quantity from other details table, and I selected other date from other table. So just practice, work with it very well, and yeah, with time you fully grasp how joins work once you practice very well. Yeah, that'll be all.
Okay, did we have any other questions we didn't answer? Steph's question, she talked about the single letters P and OD. Did you go over that?
Okay. The single letters are just aliases I gave my tables because I do not want my query to be very long. Because if I had, I mean, I can write customer dot customer ID and it will still work. But sorry, yeah, because I already put an alias, so I mean, this wouldn't work. But if I remove this alias and I decide to do customer dot company name, um, customer dot contact title, you see that the query is getting unnecessarily long and it's not even very readable. I'll just return this and I would do this join on customer ID is equal to this. I mean, this would still work, but it's just always advisable, or that's just how I prefer to write my queries. I prefer to give each table an alias, so that way I know that when I'm dealing with table C, it represents customers, and when I'm dealing with table O, it represents others, and when I'm dealing with OD, it represents other details. I mean, it's not compulsory, but it's just advisable to give your table aliases because most times you'll be writing very, very complex queries, and you wouldn't have that time to be doing customers dot all the time. So it's just advisable, or it's probably a standard way of writing your queries. I might be wrong, but like it's just my personal preference. So you could do what works for you. Yeah.
That's right. Thanks, Susan. So Steph, you got that? It just makes it a little bit quicker and easier with your queries. That's right, Jonathan. Table nicknames. It's kind of how that works. All right. Any more questions about joins, y'all, today? So we can move on to Evelyn's portion. I'll give y'all a few more minutes to think about any questions. All right, Evelyn, when you're ready, I'll hand it over to you.
Thank you so much. That was an awesome session, Susan. So, in the next session, I'll take you through the aggregate functions. So aggregate functions, we use aggregate functions to perform calculations on a set of rows in a table, and we use them to summarize data in queries. So aggregate functions are often used with a group by clause because they usually work on groups of data, but oftentimes they will work on an entire table. So these are the most commonly used aggregate functions. We have count. Count returns the number of values, and under count we can have count all. So this asterisk represents all, and we have count distinct. So count all returns the count for the number of rows in an entire table, and count distinct returns only the count of how many unique values we have in that column. And then we have sum. Sum returns the total sum of all values in a table. And then average returns the average value of a column or columns. Then we have minimum and maximum. So minimum returns the minimum value in a selected column, and maximum returns the maximum value in a selected column. So I also put distinct in here because sometimes we use it with an aggregate function, and distinct returns unique values in a selected column. Okay, I'll go next. So I got some questions that we can use to perform some calculations in our tables, and we're going to use the products and the order details table. So I'll go through the first question. The first question is, how do we get the quantity sold by each category? So in this question, we want the category and we want the quantity sold. So I will share my screen and I'll take you through the codes. Share screen. Let me share my screen again. Okay. I do not know why it's. Let me see.
I could see your screen a second ago when you shared it.
Yeah, I think you just have to minimize the other tabs that you
Alright,
have open.
can you see my screen?
Yes, ma'am, we can.
Yes.
Can you see the code there?
Yeah.
All right, perfect.
Yes, just zoom in a bit, please.
Let me zoom in.
That's good.
There we go.
All right,
Perfect.
awesome.
Awesome.
All right, so I'll take you through the first question. How do we get the quantity sold by each category? All right, so here we'll use the order details table and the products table. And so we can go ahead and, so we can see the order details table. We have the order ID and the quantity. And from our products table, we will use the product ID to join both tables. So we want the category ID, and then we want to get the total quantity of each category ID. So we're going to start from our order details table. We want, if we run this order details table, so we have order ID, product ID, unit price, quantity, and discount. And from our products table, we have product ID and category ID. So from our order details table, we're going to get the sum of the quantity, and we're going to give it an alias as the total quantity. And then we're going to select the category ID from our products table. And then Susan has taken you through the joins. So we're going to join our products table on our order details table dot the product ID, because that is the matching column in both tables. So we're going to do on order details dot product ID equals products dot product ID. So we can see product ID matches in both the products and the order details table. And then we're going to group by category ID, and we'll order by category ID. So when we run this, we see we're going to get each category ID and the total quantities. All right. Okay. So question number 2, we want to calculate the subtotal for each order. So in this, we're going to use the order details table. And if we go back here, so we can run. So we're going to run the order details table, and we want to get the subtotal for each order. So we're going to use the unit price column, the quantity, and the discount. And so we're going to do from order details table, we are going to select the order ID, And then we're going to get the sum of the unit price, times the quantity times the discount. So we're going to get the subtotal of each order after the discount is applied. So from order details table, we're going to select the order ID, the unit price times the quantity and times the discount. And we're going to give that an alias. We're going to call it a subtotal. And then we're going to group by order ID column. And then we're going to order by the order ID. So if we run this, see, we're going to have order ID, each order ID, and the subtotals. So that was the subtotal for each order. So from the order details table, we select the order ID. If we check the order details table, we select the order ID and then the unit price, the quantity, and the discount. But we're going to get the sum of these three columns. The sum of the unit price times the quantity times the discount, which is 1 minus the discount. And we're going to give it an alias as the subtotal. And then our result will be the order ID and the subtotals. All right, if I go to that question says the team wants the total sales for each product after the discount is applied. So how is that calculated? So we want the total sales for each product after the discount is applied. Total sales for each product. All right, so here we're going to use our products because we want the total sales for each product. So we're going to have the product ID, the product name. Then we're going to use the order details table because we need the total sales and the discount after the discount is applied. So we'll have our products table. We're going to use the product ID and the product name. And then from our order details table, if we run this, we're going to get our calculations from this. We're going to get the unit price, the quantity, and the discount. Okay, so we'll go ahead. So from our order details table, we are going to select the order ID and the product ID. And then from we're doing an inner join because we want the total sales. We want the total sales for each product. So inner join products, and in our products table, we are going to have the product name, only the product name from our products table. And then from our order details table, we're going to have our order ID, our unit price, quantity, and then discount because we want the total sales for each product after the discount is applied. So from our order details table, we're going to give it an alias Y. We're going to select the order ID column and the product ID. And then we're going to get the unit price, the quantity, and the discount. And then we're going to have a calculation here. So we want the unit price times the quantity times 1 minus the discount. And we're going to give that an alias, so sales after discount. And then we're going to join our products table. So from our products table, we want the product name. We're going to join our products table on the product ID. So we see from both tables, our order details table has the product ID and our products table as well has the product ID. So we're going to join on the product ID. So on X, which is our products table, X.product ID and Y.product ID. And then we're going to order by order ID. So if we run this, we're going to have our order ID, our product ID, our product name, and then we'll have the sales after discount. So this is the column that we want because the question says we want the total sales for each product after the discount is applied. So in this case, we can see that we have this ID has 3 different products, and it will result to 3 different total sales. So that's how we do that question. So I'll redo it again. So from our order details table, we want the total sales for each product. So from order details table, we'll get the order ID and the product ID, and then we'll get the unit price, the quantity, and the discount, so that we can calculate the sales after discount. And then we're going to have an inner join on products because we want the product name, and we're going to join on the product ID column. And this is your result. All right, going on to the next. So how do we get the top 10 most expensive products? So when you look at this question, we see we have a keyword here, product. So we will use the products table, and we want the top 10 most expensive products. All right, I'm gonna go next. So in this case, from our products table, we want the top 10 expensive products. So from our products table, we want the product name, and we're going to use the distinct function to get the unique. Remember earlier we said the distinct value returns unique values in a selected column. So we will want the distinct product name, and we're going to give it an alias as 10 most expensive products, and then we'll want the unit price. So from our products table, we'll select the distinct product name and the unit price, and then we're going to order by the unit price in the descending order. And the question says, how do we get the top 10 most expensive? So we're going to limit our query by 10 to get the top 10 most expensive products. So if we run this, so these are our top 10 most expensive products. So from the products table, we're going to select distinct because we want unique values, unique product names. We're going to select distinct product names and their unit price. And then we're going to order by unit price descending. So we see this is the most expensive product, and we'll have the top 10. And then we're going to limit 10 because we want only the top 10. Alrighty, I will go to the next question. So which products are above the average price? So when we read this question, we see we want products, which we're going to use the products table because we want the products that are above the average price. Then I will go to the next one. So first, we can get the average price from the products table. So we're going to do select average unit price to just get the average price. So if we run this, we're going to see this is the average price, 28.83. And then we want the products that are above that price, whose unit price is above that price. So we'll have from our products table, we're going to select the distinct product name because we want the unique product item and the unit price. And then in our where clause, where unit price, because the question is which product is above the average price. So we'll have where the unit price is above, and then we're going to have like another select statement. We're going to select the average unit price from the products table. So from our products table, we are going to select distinct product name and the unit price where the where condition, where the unit price is greater than, and then we're going to have another select statement where the unit price is greater than the average. So where the unit price is greater than, so we're going to select average unit price from products, and then we're going to order that by unit price. So if we run this, we're going to see we have our unique product names and their unit price. So we can see all these products have a unit price greater than 28.83 because that's the average unit price from products. So for products, we're going to say product name and the unit price where your wear condition where the unit price is greater than the average. And to get our average, we're going to do select average unit price from products. So where unit price is greater than select average unit price from products, and then we're going to order that by unit price. And then I'll go to the next question. So we're told to select the maximum and the minimum unit price in the product table. So we're using the product table and we want the maximum and the minimum unit price. All right. So from our products table, we're going to select maximum unit price, and then we're going to give it an alias as maximum price. So from our products table, we want the maximum unit price. If we run that, we're going to see this is the maximum unit price. And then we also want the minimum unit price. So we're going to do the opposite. So from our products table, we're going to select the minimum unit price and we're going to give it an alias as min price. And when we run this gives you the minimum price. So from products, we're going to have select maximum, max, and then the column name, which is the unit price, and give it an alias as maximum price from products table. And then the opposite for minimum. From products, we are selecting the minimum unit price as minimum price. All right. Any questions? So I'll give it off to our collaborator.
Awesome. Thank you so much, Evelyn. That was super helpful. Do we have any questions from the viewers, participants? Any questions over anything Evelyn went over today? I was gonna quiz y'all to make sure y'all was paying attention, but I think y'all got what she was talking about. So I'm gonna save the quiz for next week. All right, y'all. Okay, so perfect. Somebody just dropped the survey form. Y'all see that in the comments? If you would, and we would greatly appreciate it, make sure you go into that form and give us some feedback on today's session. Make sure you let us know what we did great, what we can do better, what you would like to see. Any kind of feedback y'all can give to us for these sessions will be great, because the better we make this, the better it is for everybody, for us, for you all. We really enjoy you coming, so we want to make sure you keep on coming. So thank you, everybody, for coming. I had a great time as well. Good job, everybody. All right, so this is SQL Saturdays. Thank you so much for participating. Make sure y'all fill out that form, and we will see you next time. Anybody want to follow up with any of the team's contributors today? This is their information. You can make sure you follow them on Twitter. They are on the Discord community, so if you do have questions, make sure you are participating in the Discord community. You can find all these lovely ladies on LinkedIn. Connect with them. Ask questions. If you want to participate, the Discord community is where you can get that started. So thank you all for coming today. We'll hang back for a few moments for any questions that you may have, but we really appreciate y'all. That's right. We're here every Saturday at 1:30, and we have more activities to come. So make sure you stay tuned for everything we have going on. Thank you for dropping that form, Alexis. We'll hang out for a few minutes for questions, and then we'll see y'all next time. Thank you, ladies.
Thank you so much.
Thank you.